record. Quadratic functions, so section 3.4. So we need to realize that a quadratic function is a function of this form. So just like your quadratic equation or function. So a graph of any quadratic function, no matter what a, b, or c are, is always going to be a parabola, no matter what. A nice parabola. So this is the graph of a quadratic function, just a parabola somewhere. Where it is, I don't know. It's a different story. But it's either going to look like this if a is positive. So if a is greater than 0, then you have a normal looking parabola. If a is less than 0, then by the transformation that we talk about, you put a minus in front, it flips the graph over the x-axis, but you'll just have an upside down parabola. That's the story. So this is if a is less than 0. The parabola has a very nice point, either the lowest point or the highest point. That's called the vertex of a parabola. So it will actually tell us, in the first case, if a is greater than 0, this parabola has the lowest value. We can find the minimum value of this function. And you can see it visually, right? The smallest value that this function can be is whatever the y value of that vertex is. Do you agree with that? So in this case, the parabola, this function, has a minimum value. In this case, it doesn't have a minimum value, but it has a maximum value. It has the highest point that this function can get to. Because we'll be doing problems. I'll give you a function and ask you, what does x have to be in order for this function to get to its maximum? So you're looking for the vertex. You want to find the coordinate of the vertex. Or lowest value for the first example. You're looking again for the coordinate of the vertex. Remember we did a problem with cows and the fencing next to the river? Same kind of thing. We'll be able to set up functions that are probably going to come out quadratic, and by finding the vertex, we can either find the maximum possible area or the minimum cost or whatever it is we're trying to do. We'll be able to do what is called optimization problems. Yeah, that's kind of powerful thing that you can analytically find those points. So this function has maximum value. Both of those, the maximum and they're located at the vertex. So when we down the road, if I ask you find the maximum, the minimum, you're looking for the vertex. That's all you have to understand. Is that okay? Now finding the vertex is a total different story, and that's what we're going to focus on for the next few minutes. But any questions? Do you understand why they look, upside down with a negative? So every time you have a parabola, you have a function that has a negative next to the square, its graph is going to be an upside down parabola. So let me do an example. F of x equals negative 3 times x plus 1 squared minus 4. Just made one up. Do you all agree that that's a quadratic function? Because if you were to open up all the parentheses, it would look like a quadratic function. But we like our functions in this form. Because if you think about this, if I ask you, can you sketch the graph of that thing? You'll feel at least you should feel really confident in sketching the graph. You know you're going to start with a parabola. Where is it going to go? What is the plus 1 on the inside going to do? Left 1. What is the negative 3 going to do? Negative is going to flip it. 3 is going to stretch it, but it's hard to see. But flip it is the bigger part. What is minus 4 going to do? Down 4. So it goes down 4. So negative 1, negative 4. And that's a kind of a skinny upside down parabola. Right? Does this function have a maximum or a minimum value? maximum, right? And you know what that maximum is. You know the location of the vertex is -1, comma -4. The maximum value of this function, the maximum value is -4. That's as high as this function can be. The location of that point is -1 on the x-axis. So sometimes you're going to be asked this question: what does x have to be in order to obtain the maximum value? So x has to be -1. What is that maximum value? -4 in this case. Does that make sense? So if you can do a quick sketch, you can find the vertex. So we like this form. Let's call it, what do you want to call it? A friendly form or a standard form. What do you want to call it? Let's just decide. I will call it from now on, regardless of what book says. Happy form? Happy form. Happy form of quadratic function. I mean, we have to lighten things up when we can. Function. So I can always say that a function, a quadratic function, can be written like that. Okay, so that's the happy form. Where is my happy form? Happy form. So right away, the vertex is going to be at hk. Right? You go h left, right. If h is positive, you go to the left. If h is negative, you go to the right. And k up and down. So just like in our case, look at that. If you match our parabola, the value of h is -1, the value of k is -4. Figure that when you match them. So -1, -4, or hk. Does that make sense? Who's with me? So the parabola is in that happy form. First, you have to be happy, and then you'll just answer whatever question I throw at you, right? If I just give you find max or min of this parabola, and we'll just write it like this. You don't even need to graph it in order to find the maximum or the minimum. Because you see the vertex. It's in the happy form. What is the vertex of this parabola? Well, 4 is the y value. What is the x value? 3. Is this a maximum value or the minimum value? Minimum. Because it does not have a negative, so it's a normal parabola, right? So if the... What? But again, because negative is already part of that formula. And then again, where are you going to shift? You're going to shift 3 to the right. You're going to shift to +3 and up 4. So that's where that goes. But yeah, so you just look at 17. If 17 is positive, it's a normal parabola, so just picture that it has a minimum. If you have a negative coefficient, then it's upside down, and it has a maximum. Is that okay? So life is good when we're in a happy form. Because you know what I'm about to do, is to give you just whatever form of a quadratic function. So let's talk about that example. So yeah, so this is a minimum. So minimum is, y equals 4 or whatever. And it's obtained when x equals 3. Okay? If this was a function of representing the cost of producing chairs, and I would ask you, at one point, do you minimize the cost? You will say, well, when I make, 3 chairs, then the cost is 4, and that's as low as it can be. That's kind of like an application of that. Weird numbers, but that's the idea. Okay? So you want to find that optimal amount of chairs that need to be made in order to minimize the cost, right? If you start making more than 3 chairs, then you maybe have to hire another shift, open another factory, cost went up. If you make less than 3 chairs, you're just being inefficient. You can whip some of those people to work and make some more chairs. So 3 is the optimal choice for this particular function. Does that make sense? Okay. Well, let me just write a function. Is that a quadratic function? Will this function have a maximum or minimum? What? Minimum, that's right, because it's a positive leading coefficient and it's minimum. Can we find that? Can you just see the vertex just by looking at this function? No, you cannot, because this is not in a happy form. If this function was written in a happy form, we would be able to see the vertex. So, I'm going to ask you this question for the third time this semester. When you see an expression like that, and you want to make it to look like this, what is that fun operation you need to do in order to pack all those random floating x's into one pretty square? What is that? We just did that last week. What am I talking about? How do you take x squared and 4x and pack it inside the square? Well, not quite. But we did that. You asked me that question earlier today. Completing the square, I have to complete the square to make it look all compact inside the square. Now, so that's the third time we're seeing that. But this time it's slightly different, because before we were dealing with equations, so we had some stuff on one end and some stuff on the other end. So we would be adding a number to the left side and then adding the same number to the right side. Well, although it appears that I have an equation, it's not an equation, it's a definition. This function defined as that. So I don't have another side to add numbers to, okay? But we can avoid that issue. Let me show you a little trick. Because remember your steps when you complete the square when solving equations. First, you don't care about that constant. Remember that? That was the first step. Whatever the constant is, you would subtract it from another side. So I still don't care about that constant. I'll just keep it there though. So there's that plus 7. Your second step was to get rid of the coefficient in front of the square term. Well, I don't have a coefficient in front of the square term, so I'm not even going to worry about it at the moment. Okay? Now the third step was to complete the square. So now, do you remember what we do with that number by now? What do we need to do? But before we square it, half it. That's right. We're going to take 4, and we're going to add. So it's basically we're doing, in order to complete the square, we're taking this number, so it's 4 over 2 squared. Right? That's that missing piece. That's always the same approach. So what do I need to add in order to complete the square? 4. Right? Well, I just changed my function. I just walked over to my function and I added 4 to it. And I don't have another side to add 4 to. Do you agree with that? So how do I make it right with the rest of the universe? If I add 4, I'm going to subtract 4 at the same time. I added 0. That's perfectly legal. Remember, multiplying by 1 and adding 0 is okay. But the benefit of that the first 3 terms now collapse to a perfect square, x minus 2 quantity squared. While the last 2 terms, negative 4 plus 7, give me just plus 3. So that's my function. Yes? That one? To offset that 4. Because I added 4, so I changed the function, so I have to subtract 4 to make it back. So I basically, this is 0. I added 0, which is fine, doesn't change anything. But I did it creatively. This 4 went inside this parenthesis, it's in there now. While this negative 4 combined with 7 to give me 3. Well, now you can clearly see the vertex, right? What is the vertex? Positive 2, 3. Right, you always go without, just like with the circles. Where's this? If this was a circle, you would go positive 2. Yeah, but again, think about the transformations. You're going to shift the parabola 2 to the right. So that's positive 2, and then 3 up. So it's 2, 3. So the vertex is 2, 3. So that's the minimum value of this function. Now let me show you on the graph. If you go to full plot, and I'll graph this x minus 2 squared plus 3. you know, here's that graph, right? And if I go ahead and graph x squared minus 4x plus 7, it should overlap that graph perfectly, right? We still see, yeah, there are two of them in there. I don't know what I'm doing. I'm changing colors, but we don't see that because they're just overlapping each other, right? There's no other parabolas. It's the same graph in there. So isn't that a sneaky way to do the square? I mean, the only difference is instead of adding 4 to both sides of the equation, I'm adding 4 and subtracting 4 at the same time. It's going to get a really sneaky if I put a coefficient in front of x squared, because I don't have two sides to divide by. Remember with equations, we would divide both sides of equation by whatever the coefficient is. Well, I don't have that ability. I don't have that side. So let's try this example. Again, find the maximum, minimum, whatever. So f of x equals negative 2x squared plus, well, let's be nice. What will be a good number to add? Maybe 12x minus 5. Okay. That negative 5, by the way, that's the y-intercept. Whatever the constant is, that's the y-intercept. You set x equal to 0, you're left with negative 5. Has nothing to do with the vertex. But I can still find that by completing the square. Now you're really going to like this method. So don't write this down. I want you to listen, because it'll take you 12 seconds to copy the final result. So, but let's again review the steps. First step, ignore the constant, so I'm definitely going to do that. So I'm going to write this down, f of x equals whatever, so negative 5 just kind of stays there. So if we were solving equation, you would divide both sides by negative 2, because you want to get rid of that coefficient, right? Well, you don't have both sides to divide by. So the only way to remove this coefficient from x squared is to factor it out. Just by looking at the first two terms, I'm going to pull negative 2 out. So that leaves me with x squared minus 6x, right? And I'm going to leave a little room in there so I can complete the square. So I'm just going to complete the square inside this little parenthesis. See what I did? So again, I'm just looking at x squared minus 6x. Yes? Oh, because I'm taking a negative out, right? So the signs change. If you distribute back, you're going to get positive 12, right? Is that okay so far? So ignore everything else. What do I need to add inside this little parenthesis in order to complete the square? What? 5? 9? Oh, yeah, 9. Did you say 9? I heard 5. 9. How did you get 9? Whoever got 9. Well, 1/2 of whatever that number is, yeah. So it's 6 over 2 squared. So you're going to add 9. Right? So now whatever's inside that parenthesis is a perfect square. That factors into a perfect square. Okay. So far? So now really pay attention. By how much did I just change my function? What did I really, by adding 9 inside the parenthesis, what is the change in my function? Can you measure that? Did I just add 9 to the function, or I did something else? Well, actually I subtracted 18. Because look, by adding 9 inside the parenthesis, that 9 is multiplied by negative 2. So I really subtracted 18 from the whole function. Figure with that? So if I subtract 18 from the whole function, what do I need to do to make it right? Add 18. So I'm just going to add 18. So this is the weird part. You really have to pay attention to the coefficient on the outside. Although you added 9, that 9 is multiplied by negative 2. So you really subtracted 18. Yeah, is that fun? Don't you wish there was an equation? You just divide both sides by 2, and you don't need to worry about it. And I have to keep track of that. So we added 18 to offset us subtracting 18. Because look, if you were to distribute the -2, let's do it in our head, you'll get -2x squared plus 12x minus 18, right? And then you have a plus 18 to offset that. So it's still same function that you started with. Yeah? All right. So then the rest is, it's -2 times x minus 3 squared plus 13 when you combine like terms. So now that's in a happy form. Right? Now you can clearly see the vertex. That -2 has nothing to do with the vertex. It's just whatever's inside the parentheses and whatever's outside the parentheses, that number added. So what is the vertex of this parabola? 313. Is that a maximum or a minimum? Maximum. Because of the negative up front, it's an upside down parabola, so it has a maximum. This is the weird connection.
So if it's plus 3.
Oh, it will still be a maximum. It's all about this sign right here. If it's a negative in front, the whole thing, that's what flips the parabola. Right? The leading coefficient, the a value, is it positive or negative? If it's positive, then it's a normal parabola. So it's, just by looking at the graph, that's the smallest value on this function. So it's minimum. And if it's an upside down parabola, the vertex is the highest point on that function. So that's the maximum. How is that? Yeah? Good? Isn't that fun to complete the square on quadratic functions? It's harder than doing it with equations, because you don't get to divide or add or whatever. You have to keep all the junk in there, because that's not an equation, that's a definition. Okay. We're good? All right. Well, now, let's say I'm going to take this function, f of x equals -2x squared plus 12x, what is it, minus 5? For whatever reason, when I toss this marker up, or whatever this thing is, this writing utensil, up in the air, it draws a parabola, right? The path of a marker is a parabola. So let's say somehow this is the function that models the path of that marker. So I can ask you this question. When will this marker be 5 feet above the ground? That's a legitimate question to ask. For our purposes, here's the flight of the marker, and let's say 5 feet, hopefully somewhere here. If I were to ask you this question, how many solutions would you get? 2. So you're going to reach 5 feet on the way up, and it's going to reach 5 feet on the way down, right? Now, what is the highest point of that marker? Look at the previous page when we dissected that function. What is the highest height that this marker can obtain? Well, 13, right? So this is 13 feet. So that happens only once, 3 seconds after I threw it up, right? X was 3. And what if I ask you how many times or when will this marker reach the height of 20 feet? Never, right? 20 feet is somewhere here. And again, we're just talking philosophically about this situation. I'm not actually going to go and solve, because in order for me to answer the first question, when it reaches the height of 5 feet, reaching height, I'm not writing this day, of 5 feet. So I'm solving this equation, f of x equals 5, right? So really, this is my equation, 2x squared plus 12x minus 5 equals 5. And I'm going to solve this equation, and how many solutions am I going to get? 2, right? This will have 2 real solutions. Whatever they are, I'm not going to find them. You should be able to, if I ask you solve this, you should be able to solve this, right? It's just a quadratic equation. But who's with me on this idea? So any point up to 13 feet, you'll reach twice, right? If I ask you when we reach the height of 11.5 feet, you'll set the function equal to 11.5, and then solve for x. You'll get 2 answers, one on the way up and one on the way down. Is that okay? But you'll get 2 real solutions. If I ask you reaching the maximum height, in our case, that's happened to be 13 feet, but let's say I don't know about this. So it's f of x equals the maximum height. In our case was 13. I will solve this equation, negative 2x squared plus 12x minus 5 equals 13. How many solutions will that equation have? 1 solution, right? Somebody already mimed that, because you're going to reach the maximum once. Actually, if you really pay attention to the flight of the marker, it goes up, and then there is a moment of weightlessness. It's not moving. So it's actually experiencing 0 gravity. Moment of, that's going down. If you jump up and down, you have a moment of weightlessness in there, okay? So reached once. And then finally, if I ask you when this thing reaches height of 20 feet, you set your function equals 20, no real solutions, right? Never reach that height, right? So now there's a case when you get 2 real solutions, there's the case where you get 1 real solution, and there's the case where you get no real solutions. And we talked about that at the end of last class. Almost not the very last thing you wrote in your notes. The very last thing you wrote was solving equations of quadratic type. But the thing right before that's dealing with the discriminant. You remember that? The discriminant is the expression under the square root. It's in your notes. The b squared minus 4ac under the square root of a quadratic formula. If that b squared minus 4ac is positive, you get 2 solutions. If it's negative, you get no real solutions. But if it's 0, you get 1 real solution, right? So in order to find the maximum, because this is what we're about here, we're trying to find the vertex. We found one way, completing the square. I'm about to give you something a lot juicier. The maximum, the vertex, happens when equations have only 1 solution, meaning the discriminant is 0. Well, if the discriminant is 0, here's the quadratic formula. If the discriminant is 0, what is left out of a quadratic formula? If you let discriminant equal 0, remember the discriminant is the radicand. So if that equals 0, what's left? Negative b over 2a. So the x value of the vertex is always negative b over 2a. That's it. Isn't that lovely? I don't think you understood what just happened. Because I didn't, see, I'm too nice to you. I didn't make you suffer enough with completing the square to just kind of hand this thing to you. That the x-coordinate of the vertex is always negative b over 2a. Check this out. Here's this function, right? Negative b over 2a, so it's 4 over 2 equals 2. So 2 is the x value of the vertex. Bam, 2, right? Here's another one. Negative 2 and 12. So negative 2, negative b over 2a, so it's 12 over 4. 3. 3 is the location of the vertex. Bam. So you just get the x values for free. Negative b over 2a. Isn't that nice? So now answer this question. If you know the x-coordinate of the vertex, and you know what the function is, how do you find the y-coordinate of the vertex? You know the equation for the function. So that tells you the y value of any point. At any point x, the function will tell you how high it is. Plug it in. So the second you got your vertex, substitute it back into your function, and this is your y value. So it's negative b over 2a, whatever that is, plug it into your function, that's going to be the y value of that vertex. Don't believe me? Let's take that function we just played with. Well, first of all, write this down. That's the big thing. I might still ask you express your quadratic function in a happy form, but to find the vertex, if you just have to find the maximum and the minimum, negative b over 2a. It's just be a quadratic formula without the square root, because the discriminant, was I saying this determinant before or discriminant? What? Yeah, I need to play back what I was saying. I should have been saying discriminant. Was I saying determinant? I meant discriminant. But anyways, f of x, what was that, negative 2x squared plus 12x minus 5? Was that the function? No? Yeah. So then for the vertex, x equals negative b over 2a, so that's negative 12 over 2 times negative 2. Right? Three. X value is 3, so that's the x coordinate of the vertex. The y coordinate, well, that's just f of 3. So that's negative 2 times 3 squared plus 12 times 3 minus 5. I'm pretty sure it's going to equal 13, because that's what we got before, but this is negative 18 plus 36 minus 5. Yes, that's 13. So the vertex is 3, 13. I thought you were going to be a lot happier about this. You're not excited about this discovery? Not so much? You just say, I didn't, that's probably my fault. I just gave it to you too fast. I should have made you to like complete the square for a while, throw some fractions into those things. You know, so you have factor and then add, subtract. Don't forget about, but negative b over 2a, it's magic. Right? Well, it's mathemagic. So remember we did that cow problem? You know, the fence next to the river. Let's do a very similar one. Now without graphing. So I want to do it like this. I want to build a fence next to the river. I want to split it into 3 parts. Here's the river. So these are my x, 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 x. And that side is y. And we have the total. We have 3,200 feet of fencing. So I want us to find the dimensions of this lot so it maximizes the area. So the question is maximize the area. Provided we're building a rectangular lot. Because you can, technically you can build a bunch of ellipses, maybe they'll maximize the area. But let's keep it simple with rectangular lots. You realize that I can draw 2 different rectangles of the same perimeter, but they'll have different areas. Are you okay with that concept? Yes? If I can do 10, 20, What is the perimeter? The perimeter is 60, right? If you add all the sides. So the perimeter equals 60. The area is what? 200. But if I build at 5, 5, and then what, 25, 25, the perimeter is still 60, right? But the area is 5 times 25 is 125. So it's a smaller area than the first rectangle, but has the same perimeter. Do you know the shape that contains the largest area for the fixed perimeter? Square would be the largest rectangle. The largest shape will just be a circle. Circle contains the largest possible area for a fixed perimeter. So if they gave you 32 feet of fencing and just ask you to build a fence, build a circle. You know, if you don't have a river. So build a circle. They'll contain the largest area enclosed. More than a square. Okay? All right. So the area in this case is just x times y. Right? That would be the area of that shape. Do you agree with that? It's a big rectangle, length times width. Now, there are two variables. We cannot solve. Well, we're going to deal with functions with two variables, so we need to do something else. So that's where 3,200 feet comes in. And the way we did that before, if you add all the sides together, you should get 3,200. So that's 4x plus y equals 3,200. So it's really a system of two equations. We haven't done systems yet, but you should be able to realize that, you know, I can solve for y. Y equals 3,200 minus 4x. And I can take that expression and substitute in for the y value in my area function. So then the area, now a function of x, equals x times 3,200 minus 4x. And if I distribute x, it is negative 4x squared plus 3,200x. What do you think? Is that nice? It's a quadratic function. Does it have a maximum or minimum? Maximum because it has a negative in front of the square. So I can find that maximum value by finding the vertex. And all I have to do is just go negative b over 2a. I don't have a c, so who cares? It's negative b over 2a. So the x is negative b over 2a. So that's negative 3,200 divided by 2 times negative 4. So it's 3,200 divided by 8. What does that equal to? By, yeah, 8. What? 400. So yeah, x has to be 400. So if x is 400, the rest is y. Y equals 3,200 minus 4 times 400, so equals 1,600. So that will be the dimensions of that lot. 400, 400, 400, 400, 600 on the top. That will contain the maximum area. We can find that maximum area by plugging 400 back into our function. The actual maximum area so it's a of 400. So that's negative 4 times 400 squared plus 3,200 times 400. Right, that was my function. I just plugged in x. I just plugged in 400 for every x. Whatever that equals to, it's probably actually easier to plug it in into the factored form. It's 400 times 1,600, so it's 64 many zeros. I'm just gonna guess 1600 times 4. I need another zero. Is that right? If I compute that value? Yeah, 640,000 square feet. So that's the maximum area that we can obtain with the given amounts of whatever. How's that? Okay, so who is But yeah, so there are no solutions. The way you do that, you just multiply the LCD here is x minus 4, x plus 4, right? Because that one factors into x minus 4, x plus 4. So when you start multiplying both sides by that, in the first one, x minus 4 cancels, you're left with x times x plus 4. In the middle one, x plus 4 cancels, so that minus 4 times x minus 4. And on the right, the entire denominator cancels. You're left with 32. Right? So then you distribute x squared plus 4x minus 4x plus what? Is that right? Yeah. Plus 16 equals 32. 4x cancel, subtract 16. X squared equals 16, so x is plus or minus 4. None of those two work, right? They both turn your denominator into 0, so both extraneous. So no solution. Questions on this? Does that make sense? So it's really coming down to your ability to factor and find the LCD. If you can do that, then you are in a pretty good shape. And you should know how to do that. So before we go into finding the LCD and all that, we have to try and factor that. Okay, we have to try and factor the denominators. So the middle one, there's nothing you can do about the middle one. X over x plus 2. Can we factor the first denominator? X squared minus 2x plus 4. And if yes, how? How would you factor the first denominator? All right, well, let's wait. How would you factor the last denominator? X cubed plus 8. X plus 2 is one of the factors. Okay. What is the other factor? Because you're thinking of this as a sum of two cubes, right? X cubed is a perfect cube, and 8 is a perfect cube. So you really need to remember this fancy formula, the sum of cubes formula. Some of you probably know that formula. I'll give you that formula on the test. You don't need to have it memorized. You just need to know that it's out there and you need to know how to use it. The formula for the sum of cubes is a plus b, and then it's a squared minus ab plus b squared. So when I'm trying to factor x cubed plus 8, a is just x, and b is 2, because 2 cubed is here, right? 8 is really 2 cubed. So this is why my first parenthesis is just x plus 2, a plus b. Okay? So then the next parenthesis is a squared, so in our case, it's x squared, minus ab, just the product of 2 and x, so it's minus 2x. And then plus b squared. B was 2, so 2 squared equals 4, so here it is. So it's the x cubed plus 8 factors into x plus 2 times x squared minus 2x plus 4. Okay? Now, should we even bother factoring the first denominator then? because it's, I mean, it's x squared minus 2x plus 4. It's already there. Actually, you won't be able to factor x squared minus 2x plus 4. Yeah, you cannot find that. You know, if there was a 2AB, remember the 2AB formulas, then you can factor it. That does not have it. Actually, the way, there is a special name for these types of trinomials that don't have a 2. They're called degenerate quadratics. I'm not making this up. This is what they call them, degenerate quadratics. Did not develop that extra 2 in the middle, so you cannot factor them. But anyways, so that's that. So what is the LCD? When it's all done and factored? Yeah, so it's x plus 2, and that's trinomial. So the big hurdle here was to factor those things properly. So the sum of cubes, you'll see that on a test. You'll see sum of cubes on a test. I'll give you the formulas. There's also a formula for the difference of cubes. If there was an a cubed minus b cubed, then the first parenthesis would have a minus, and the second one will have a plus. So, but I'll give you those on the test. You don't need to have them memorized. But we'll do the same thing. You multiply the first one, the big trinomial cancels, and you're just left with 8 times x plus 2 equals, in the middle, x plus 2 cancels, and we're left with x times x squared minus 2x plus 4, right? And on the last one, the entire denominator cancels plus 24. Okay. So no more denominators. Now we can open up all the parentheses, combine like terms, just solve a regular polynomial equation. So it's 8x plus 16 equals x cubed minus 2x squared plus 4x plus 24. Is that okay? Just opening up the parentheses. Now if I move everything to the same side, subtract 8x, subtract 16, we'll get x cubed minus 2x squared minus 4x, right? You subtract 8x from 4x, and then plus 8, right? You subtract 16, subtract 16, subtract 8x, subtract 8x equals 0. Oh, you have to go further. You have solve for x. You just got another equation. Well, okay, so it's a cubic equation. The only way we can attempt to solve this equation is to factor that and set each factor to 0, because that process still works, the zero factor property. So you have an expression with 4 terms, nothing in common. How can you factor something like that? What is the technique you have to utilize? Well, but there is no common x, right? Yeah, you have to group it. You look at the first 2, right? You take x squared out, leaves you with x minus 2, factoring by grouping. So then in the next 2 terms, you have to factor it in a way so another x minus 2 appears. You want another x minus 2. Otherwise, it will not work. So what do you need to take out of the last 2 terms to get x minus 2? Negative 4. Right? So if you take negative 4 out of the last 2 terms, you'll get negative 4 times x minus 2. And finally, pull x minus 2 out, x minus 2, I think, and it leaves you with x squared minus 4 equals 0. Right? You take the x minus 2 out, and then see what's left. So let me write it pretty. X minus 2. I can factor x squared minus 4, another x minus 2, x plus 2. Right? So I can even write it as x minus 2 quantity squared, and then x plus 2 equals 0. You set them both to 0, x equals 2, x equals negative 2. That square doesn't do anything as far as the solution goes. Are both of them going to work, or we have an extraneous one? Yeah, because we had x plus 2 is one of the denominators, didn't we? Yeah, x plus 2, so negative 2 will not work in there. So negative 2 is the extraneous solution, so this is the solution, and this is the extraneous. So how does that sound? Any questions on this example? It was really a math 055 problem, full of factoring and combining like terms and then factoring. You haven't really, there's nothing new in this problem. You just find the LCD, multiply both sides, solve the equation. The only new thing is check your solution, make sure it's in the domain. Right? So you have to be good at factoring. Questions? Questions on this problem? So 2 works, negative 2 is extraneous. Is that good? All right. I'm going to stop.